For example, a disgruntled employee could write a few extra line of code that activates when the vehicle is driven 5,000 miles on the road and suddenly kills the brake and causes an accident.
Yes. I mean, insider threats isn't something that just affects the automotive industry, it affects all industries. You know, it's a big concern, especially as you see more and more code being implemented in systems and vehicles. And the supply chain associated with the automotive industry is very complex in certain circumstances, and as we see more and more connected infrastructures, more and more autonomy, the inclusion of third-party apps, you know, and automotive-specific app stores, it's only going to increase. So there's always the possibility of, you know, the disgruntled employee that wants to insert some malicious code in there. But I mean, going back to my talk and the overall concept of the secure development lifecycle, that applies to all the code within the entire life cycle of the development of the different elements in a connected car infrastructure. So, you know, you need to make sure that you're auditing that code and looking for these kinds of things. But yeah, the automotive industry isn't, you know, alone in these threats. It's all industries face insider threat.
Great question. Yeah, you know, how do you secure layer 8, right? Humans are the weakest link in security. Actually, Mr. Davis touched on it as well. Like you said, the SDLC, the people that push the code should not be the same people that write the code, right? Separation of duties, ISO 27001, basic stuff. You know, it should be segregation of duties, especially with development and, you know, writing code.
Yeah, I think it's not just in the car industry, right? This is a general problem that software development has to face. The disgruntled employee. And there was another question.
Thank you. I have a question regarding the mobile communication presentation we've heard before. You have mentioned, okay, you did focus on GSM and 3G. You mentioned shortly, okay, with 4G things are different. Is the conclusion that you would say really safety-related applications and such things, what is your opinion? Do you really only see it with full coverage of 4G and higher levels, or can you a bit elaborate on that? And the second question is regarding the analysis that has been made. Has there also been any analysis being made already on short-range communication, so really direct short-range communication using Wi-Fi, like it will be mandated in the US and also developed in Europe with IEEE 8.11p on V2X. Did such tests already also happen, or did you only focus on the systems that are out there already?
So great questions. As many of you know, there's different types of penetration tests that researchers will perform. There's white box, black box, and gray box. White box penetration testing is you're given all of the material engineering documents, code. You do static and dynamic code analysis. A lot of the vulnerabilities that have published historically in this area and this industry has been a lot of the researchers had access to the source code, right? And they could code the source code looking for specific file names or what have you. Our research has always been relegated to black box penetration testing, where we had absolutely no access to source code, where we really didn't have access to engineering documentation, or we didn't, we just didn't read it. In regards to the short range versus long range, we've always done it from the perspective of long range. Our attack vectors have always been focused on wanting to be able to see what we can do remotely. A lot of research is being done. You guys have seen the YouTube videos, you guys have seen the news reports, people standing outside the car with a mobile phone, right? Or people sitting inside the car with access to the diagnostic port. We want to do our research in a different area. We want to do it with, okay, you know, the communication infrastructure that these cars and these ECUs are relying on, that can, what attacks can be actually launched remotely. So that was that question. I think I answered both questions. Did I? I forgot the second. I completely forgot the second question. I'm sorry.
I can pick up on the second question. I'll touch on the first question as well. I think what you were saying is, around the kind of real-world impact of attacks against not just 2G networks, but 3G and 4G networks. And as long as we don't have full coverage for 3 and 4G, there will always be a legacy requirement to downgrade to 2G, which will mean that there will always be the opportunity to do man-in-the-middle attacks with road base stations, that kind of thing. So I think that's a coverage issue. With regard to DSRC, yes, there is active testing and research going on with 802.11p. As you probably saw from our presentation, we've got a very kind of research-led approach to tool development. So where there's a requirement for a new tool or technique, we'll develop it to use within engagements. And we saw a while back that there was a requirement for DSRC testing tools. So we're using software-defined radio, like the USERP that we use for various attacks, to develop tool sets for testing 802.11p.
And then just to elaborate as the kind of futurist up here, 5G is really what's of most interest from our perspective in the ASRB, as we look at not only is it interesting from an infrastructure perspective, but from a point-to-point communication perspective, right? With the bandwidth, the latency, and the security inherent to the architecture, right, far surpasses anything that exists in 2G, 3G, 4G, LTE, or DSRC. And so we're doing a lot of work right now on 5G emulated roadside units with vehicles for V2X communication, as well as V2V for smart city evaluations in the U.S. There's multiple government grants that we're participating in for smart city evaluations and 5G. And so I think that has a lot of promise for the future. But again, there's challenges that exist today, and there's a lot of people that are doing a lot of great work on that.
I'd like to just add to that real fast. So I love the discussion about 5G, actually, and it makes me think about how traditional attack vectors and security, it's a game of cat and mouse, right? So in a traditional sense, in a traditional network, you upgrade your security controls to say, you put in a Palo Alto Networks firewall, you put in network intrusion prevention, you put in endpoint security, and now you've got security for the time being until anyone really comes back. What's interesting about the advancements to 5G and some of the security controls that 5G will implement is you're only as secure as long as your car is in that 5G network, right? So I think that's the really interesting dynamic to me with this area of research and vulnerabilities is your security controls are only available to you while you're in the more secure network. The second that you go to a 3G area because of lack of coverage, or because you're in the mountains or whatever, or because you're not even in Germany, let's say that you're on a road trip with your family and you've gone into an area that doesn't have 4G LTE coverage. It's just interesting to me because it's, you can enjoy those security controls in a more secure, higher band network, but you lose them as soon as you leave that area. So just
I think you're waiting.
Just a minor comment on something that Craig Hurst said. Computing is a danger for current cryptographic methods, but it's not a promise for security against itself. Quantum crypto, which has nothing to do with quantum computing, requires a wire, direct connection from point A to B, or a line of sight for a laser. So it's not useful for mobile communications, and the connected car is a mobile application. The answer is still in classical crypto, which is made to be resistant to this. So just a kind of a warning, if anybody's trying to sell you a quantum crypto method for mobile applications or connected cars, well, treat these with a bit of suspicion.
Yeah, great comment there. I mean, there clearly is a difference between quantum computing, between quantum cryptography, and quantum resistant cryptography. And what's happening in the areas of research on all three fronts, right, is quite fascinating. And just the fact that the NSA, which is probably not the most glamorous organization to stand up, right, is planning on putting, you know, these resistant technologies in place in the near future. And there's a lot of interesting research to be done on that front. There are ways to overcome it, and there's a lot of very specific, you know, implementation methods that various labs around the world are working on that will deliver some of that resistance. We still have some time to go before we see how all this will play out. But yeah, very good point. There is a difference there.
We've got a dedicated crypto team. They are days away from releasing a public white paper that's going to be freely available that talks about the implications of quantum crypto on, or rather, quantum attacks against crypto algorithms and demystifying it all, so you know, writing it all in easy to understand language, so you can understand if tomorrow somebody developed a quantum attack against crypto, how that would affect the algorithms that you're currently using. So that will be available on ntcgroup.trust very soon.
Maybe a quick and naive question. So I'm not an expert at all about security, but when I see all of you talking about a possible attack, I see in a lot of cases someone needs to prepare a patch and put the patch on the hole so no one can attack it anymore. Now, my question is there a way preventively? Because each one of you that are attacking the system somehow is sending packet or is detectable at the moment you start an attack, possibly. That is what I'm asking. Is there a way, this could be a way to solve the problem or help and give higher security? I don't know if I was clear in my statement or question.
Yeah, so I'll take the first answer. So there's some really cool tech coming out. NCC Group is obviously doing some cool research. There's a company who I think the principal is speaking here at the conference at TowerSec's been doing some pretty wickedly cool stuff. Like I said, I think security is a continuous game of cat and mouse, right? The hackers and the attackers are definitely becoming more sophisticated and becoming definitely well more funded. I think I was talking about this morning as well. So I think that'll continue to evolve. But there's definitely some great tech coming out. And I think a lot of the traditional security rules apply, like hard-coding usernames and passwords into binaries. These EDUs, these ECUs are like computers. I mean, you know, some of them are running SSH. We found one ECU where they hard-coded the root account into the SSH binary. Right? So, you know, in order for a service to interact with it, I think it's just, you know, I definitely haven't been doing this as long as these gentlemen. I mean, in 16 years, it's almost like the vulnerabilities are coming back. I'm having deja vu, you know? It's like the stuff from 15 years ago that I'm seeing come back again. I mean, you know, hard-coded root accounts in the SSH binary was something that vendors were doing 15 years ago. You know, and now some of the EC vendors are doing it again. So I think it's training developers and sending them to, you know, secure development training. It's SDLC. It's all of the same old rules apply. It's a different threat, a different day, but it's a lot of the times the same vulnerabilities.
Do you think we will reach a point in time when we have something that we consider secure? Like nowadays we probably say it's safe to step into a car because we have invented seatbelts or invented airbags. And it was a stepwise refinement process. Do you think the same will happen for security?
It's going to be a few years before we start seeing the rollout of the next generation vehicle platforms that have been developed using the secure development life cycle. But I think once we see the first of those, it's going to be significantly harder for security testers to find the kind of vulnerabilities that we're seeing today. I totally agree with the comment about, you know, we're seeing vulnerabilities that we saw 15 years ago. You know, I've been in this industry a long time, and back in the late 90s, the kinds of vulnerabilities we were seeing are what we're seeing on ECUs today. And it goes back to the embedded system mindset that I talked about.
Just to refine the question, maybe I wasn't clear enough, or maybe I didn't understand it in most cases.
This was to refine. So if I can have a great lock in my house, in the door,
wondering if some action in this direction, the automotive is worth to take something like that.
So it's worth considering the model that you should adopt when developing any complex system is having a layered approach to security. Even if somebody manages to work out the combination to the lock on your door, there should then be a whole bunch of different layers of security that they need to get through to get to the sensitive part, the safe within your house, and then they've got to crack the code on the safe. So, if you look at a connected car, you're looking at ensuring the security at the mobile network operator, actually starting at the TSP, so security of the applications and systems that the telematics service provider. You then need to make sure that you've got appropriate security mechanisms implemented at the mobile network operator, then on the TCU element within the vehicle, and then segregation between the TCU element and vehicle networks and cyber-physical ECUs. So even if an attacker manages to compromise one of those, they haven't managed to get full access to the vehicle.
I'll just comment a few things there. As for putting a badge on something, saying that this has a certain level of security, with new standards, of course, with external assessors, maybe we can reach that point. That would be really, really good, in my opinion. Similar to ISO 26262. So I think we need to get there eventually. The position of the Volvo Group is that they see hacking as a vehicle, as a crime. Although people will attempt this, obviously, and I'm glad to hear that there's some interesting tech coming up. It certainly would be useful to protect our vehicles and make them safe for the future.
Just a couple other comments to add. I agree with the comments here from the others, but having redundancy, having multiple layers is going to help. Also having technologies that can identify anomalies, have intrusion detection capabilities, have intelligence and agile cryptography built in as a design mechanism as part of your SDF process in ways that allow, for example, your neighbor's house, right, to communicate to your house. There's this weird guy walking around, right, with a lockpick, don't let anybody in, disable everything, right? In the connected environment that we're moving towards with all vehicles being connected, that's a possibility that is going to help, I think, everybody. But it needs to be done in a way where everybody can share, right, that information. There will be public platforms available for security and other elements. We're already starting to see this with mapping, for example. I mean, the German conglomerates that are purchased here, right? I mean, there's a reason behind why that's being seen as, a asset that has multiple people to take advantage of. Security may also have very common elements that people can take advantage of. And so it's no longer, siloed. In the future, it will no longer be siloed approaches, but a collaborative approach across the board where we can share the information and be agile with regards to how we're opposing those various threat vectors.
Can I add something? Are we out of time? Can I add? Really fast? 30 seconds? Okay, cool. I think we need to stop kind of looking at it as a horse and carriage. I think we need to stop looking at it as the first order. These are no longer just cars, right? These are computers. These are computer systems with identifiers on a network that you can communicate with. And I think if you look at some of the new technologies that are coming out to prevent or detect some of these attacks, it's resurgence of the same security controls that we're seeing in networks that are protecting your guys' laptops and servers in your network. It's not anything fundamentally advanced or new that no one's ever heard of before. It's firewalls and intrusion detection to automobile cars. It's just all different.
So do you have been waiting for a long time? I think this is unfortunately the last question because otherwise the lunch gets cold.
Okay. It's actually not really a question. I just want to refer to the previous question. My name is Asad Asman from Towerset. So this just mentioned earlier. And I think your point was about detection, not just the protection of the end device, but also when the attack is being mounted, can we see it in advance and maybe take some mitigation to it? And this is exactly what we're doing with TCU Shield, which is a product which is basically looking at all the different vulnerabilities on cellular communication. Some of them were mentioned in Alyssa's presentation. sometimes we just borrow a lot of the vulnerabilities that just come from different industries, from cellular world, and really when you design the system, the telemagnetic system, you don't necessarily would look at all these vulnerabilities. You'll be much more concerned with protecting the actual telematics, but not necessarily the modem. So this is where we're coming in and trying to add this additional level of protection from all these different vulnerabilities.
And on that bombshell, so to speak, thank you very much for your wonderful presentation and for answering all the